Good evening, students. This is the lecture number 11 on ray optics. In last class, we have finished our uh, lens refraction through the lens. Okay, and now we are going to our next topic, that is prism and optical instrument. So we have finished our first part of ray optics in last 10 lectures, and now we are going to the second part, okay, of this chapter. The second part is prism and the optical instrument. Okay, so the first topic is the refraction of light through the prism. Okay, what is the prism? Prism is a portion of a transparent medium bounded by two plane faces inclined to each other at a suitable angle, as you can see in the figure. Okay, so here we have to discuss the refraction through the prism, what is the minimum angle of deviation, and how to find the refractive index of a prism. Okay, so it is clear to you, a prism is a portion of a transparent medium bounded by two plane faces inclined to each other at a suitable angle. Okay, so here we have the geometry of 2D geometry of a prism. In two-dimensional geometry, it looks like a triangle. Okay. Okay, now see the figure. The figure shows passage of light through a triangular prism ABC. Okay, this is your prism ABC, triangular prism ABC. Okay, here we have two refracting surfaces. This one is first refracting surface and second refracting surface. So the beam which is incident making some angle with the normal moving from rare medium to denser medium, then again denser medium to rare medium. Okay, so after refraction through the first phase of this prism, this incident ray bend towards the normal. Okay, you can see here, bend towards the normal. Actual path of this incident ray should be this, but after refraction it bend towards the normal. This will be your normal and this is your refracted ray. This will be your angle of refraction, this is angle of incidence. Okay, now at the second refracting surface, this refracted ray again refracted by this surface, and this particular ray is traveling from denser medium to rarer medium. Okay, so according to the rules, it bends away from the normal. Okay, it should go towards this direction. Okay, but as you can see that the actual path followed by this particular ray, that is RS. Okay, away from the normal. Okay, since it is traveling from denser medium to rarer medium, so this is called emergent ray. Okay, this will be your incident ray, this will be your refracted ray, and this is emergent ray. So this will be your angle of emergent, this particular ray making with the normal. These two are normal. Suppose that these two normals are intersecting at this particular point, that is L. So AQLR is your quadrilateral. Okay, if I extend behind this particular ray, then it intersects at point O to the incident ray. Okay, to incident ray. So this will be your point of intersection, and this particular angle is called the angle of deviation. Okay, actually this incident ray should follow this path. Okay, but due to the refraction, this ray will be diverted with some angle, that is called the angle of deviation. Okay, so here we have to find the angle of deviation, okay, for this particular prism. Okay, here we have some assumptions. First one is the A is the angle of prism, I is your incident angle, R1 and R2 are the refracted angle, E is the angle of emergence, PQ is your incident ray, QR is your refracted ray, RS is your emergent ray, delta is angle of deviation, and AQLR is your quadrilateral. See in the figure. Okay, this is your angle of prism, angle of incidence, angle of emergent. These two are the angle of refraction or refracted angles. Okay, you can say incident ray, refracted ray, emergent ray, angle of deviation. Okay, and this will be your quadrilateral. Okay, so in quadrilateral AQLR, okay, the total sum of all angles is 360 degree in quadrilateral. Okay, since you can see here this is your normal, so this angle will be 90 degree and this is also 90 degree, so 90 plus 90 equals to 180. Then it is conclude that the sum of these two angle also equals to 180 degree according to the laws. Okay, so in AQLR what happened, angle A plus this angle QLR is equals to 180 degree. Okay, as you can see here, angle A plus QLR equals to 180 degree. Okay, the sum of two angles equals to 180 degree because these two are already have sum equals to 180 degree. Okay, now in if I consider this triangle QLR, then this angle plus this angle plus this angle, this angle plus this angle plus this angle equals to 180 degree. Property of triangle. Okay, R1 plus R2 plus angle QLR equals to 180 degree. Okay, in triangle QLR, R1 plus R2 plus QLR equals to 180 degree. This will be your equation number second. If I compare these two equations, the right hand side of both the equations are same, then left hand side is also same, will also be same. Okay, then what happened on comparing, angle A plus QLR equals to R1 plus R2 plus QLR. So this QLR and this QLR will cancel out each other. Okay, so we get A equals to R1 plus R2. Okay, now consider this OQR. Okay, consider this triangle OQR. Where is your triangle OQR? See the last figure. Okay, this will be your OQR. Okay, say this is your exterior angle delta, so let us consider this angle as delta 1 and this angle as delta 2. Okay, delta 1 and delta 2 respectively. Okay, so I draw again that particular triangle here. This will be your delta 1, this will be your delta 2, and this is OQR. Okay, so in what happened in OQR, here we have one angle of deviation here. Okay, as shown in the previous figure, here we have angle of deviation. Okay, so this angle of deviation delta is exterior angle for these two. Okay, so by exterior angle property, what happened here, delta 1 plus delta 2 is equals to the delta by exterior angle property. So delta equals to delta 1 plus delta 2. Okay, now we have to calculate the value of delta 1 and delta 2 respectively. Okay, so consider this point, this is your point Q. Okay, this is your point Q. So at point Q, this will be your normal and this is your angle of incident ray. Okay, so this is your angle of incidence. This angle of incidence is equals to the sum of delta 1 plus refracted angle. Okay, according to the previous diagram. Okay, so what happened here, in place of delta 1 we can write I minus R1. Okay, see here, I equals to delta 1 plus R1, so delta 1 equals to I minus R1. Similarly we can write at point R E equals to delta 2 plus R2, so delta 2 equals to E minus R2. Okay, so here we have the value of delta 1 and delta 2 respectively. Put the value in this particular equation, we get delta equals to I1 minus R1 plus E minus R2. If I take minus common from these two, so we have R1 plus R2 here. So delta equals to I plus E minus in bracket R1 plus R2. Okay. So in last in previous equation we have A equals to R1 plus R2, as you can see here, A equals to R1 plus R2. Okay, so we can put R1 plus R2 equals to A.